Hello all, welcome to the Computer Vision video lecture series. In the previous video, we have seen some of the basic operations on the images. In this video, let us continue other basic operations that we can do on the images. So let's get started. So the operation that we can do on the images are resize an image, crop an image section, image rotation, and copy a region to the another in an image. So this operation we can see in this video. So here first we will see the image resizing. So for resizing an image, this is the syntax, that is resize, then SRC. So this SRC is nothing but our source image or the required input image. Then size. Size is nothing but the desired size for the output image after resizing, or we can say it is the destination image or the after resize image. Then FX. FX is nothing but the scale factor along the horizontal axis, and Fy is the scale factor along the vertical axis. And interpolation. So this interpolation is the optional value. So it gives us the different options or the different method of resizing the image, like how you want to resize the image. So that it gives us. Now here you can see this interpolation is accepting these values like inter nearest, then interlinear, inter area, inter cubic. So again each flag is having different like resizing methods. So here for example inter nearest is there. So the nearest neighbor interpolation, interlinear. So this is the default one, like bilinear interpolation. So this is used for the default. Now for resizing image, first we want the image as a input, or we want to read the image. So first let me run this import CV2 and import numpy as a NP. Now for this resizing images, we will have the dog image. So that image is in this path. So I'm just providing here the path and opening that image or reading the image, and that is stored into the image variable. So this image is my variable. And now here with the help of I am show method, I'm just showing and displaying that method. So this is the simple syntax. So here you can see the image is there. So this is the default, or we can say it is the original image, and we want to perform operation on this image. So this is the original size. Now here I want to see the size of this image. So let me run this. So here you can see what I have written, print image dot shape. So this shape is giving me the values in the three dimensions, or the in three. So the first one is the 640, 427 and 3. So this 3 is nothing but the Chinese. So here this is the color image. So that's why it is returning the 3. Now for resizing we are having the like two methods we can say. So the first one we will be seeing here is the resize by specifying the width and the height. So here I am mentioning the width and height, and with the help of that I am resizing my image. So as we have already seen, the syntax of the resize image is we are providing the image. So here I am passing the original image. Now instead of this down point, here what I want to mention the desired height and width of the image. So that I have taken over here. Here I am downscaling my image or reducing the size of the image, that is width and height. So here I want the width as 300 and the height as the 200, and these two I am providing to this down point. So actually it is not necessary. If you want to directly want to write here like 300 comma 200, you can mention that as it is. And interpolation, so again this is the default one. Like if you are not providing, so by default it is taking the CV2 dot interlinear. So this is not the default one. Here I have mentioned this one. So let me run this, and this is what the resize image I am showing over here. So now you can see this is the resize image. So earlier image was the like the big one. Here I have downscaled that image with the 640 by 427. So this is how our image looks like. So this is the one resizing operation. Now for the second one, what I want to resize with the scaling factor. So here in the earlier case, I have only mentioned that 0 comma 0. That means that fx and fy value I have not mentioned. So suppose you want to see the syntax of that resize. So just click here and press shift tab. So you can see the syntax of that resize. So src, desize, then this fx and fy. So this fx and fy is a scaling factor values. So here I have mentioned 0 comma 0. That means I don't want to provide that. That's why. Or like you here, if you don't want to mention that 00, na, again it's okay. Now interpolation. So you can see here the function resize resizes the image src down to or up to the specified size. So if you want to resize down, so you can provide that values, and if you want to scale up, so accordingly you mention the values. Now initial destination type or the size are not taken into the account. So instead the size and type are derived from this src. The src, desize, fx and fy. So if you want to resize the src so that it fits to the pre-created dst, that is the destination image. Now you can see over here that this one, the interpolation value. So here resize is given src destination image. If you want to provide size, you provide, and if you want to provide the scaling factor like with respect to x and with respect to y, so here they have given 0.5 as that x value and 0.5 as the fy value, and the interpolation. So again they have mentioned for that interpolation, if you want to shrink an image, so it will generally look best with the inter area interpolation. So if you want to downscale the image, so that time they are saying you can use this inter area as an interpolation value. And if you want to enlarge an image, so it will generally look best with the intercubic like or interlinear. So this they have given. So accordingly you can use this. So this is the formula of the resize or the syntax of the resize function. Now here you can see we are resizing with the scaling factor. So again resize, I am providing my original image. Here I want to uh, like I don't want to mention anything like the destination image or the desired size of the image. So that's why I have mentioned none over here. And here I am like scaling down. So here that value I am specifying as a 0.6 with respect to x, and same value I am taking for with respect to y, and interpolation as cv2 dot interlinear. So let me run this, and again this is only that resize image we are storing into this scale f down variable, and that variable I have taken for displaying the image. Yeah, now you can see here this is the like resize down image with the scaling factor. Now same we are doing here, but instead of scaling down we are scaling up the image 1.2 times by specifying both scaling factor. So here you can see I want to scale up with respect to x by taking the value as 1.2, and same for y. So you can see the resize image function image, then here I am not specifying any desired image size. Fx is equal to 1.2, Fy is equal to 1.2, and interpolation value here, but default value I am taking and just printing that. So you can see this is the scaling up image, but 1.2 times. Okay. So again, if you don't want to mention this whole thing, na, so what you can do, just let me write over here and copy this whole thing. Now you can see here, instead of this, let me only type 1.2 as the scaling factor value, and instead of this again 1.2, and let me run this. Yes, so same I have written resize image. Okay, here let me write. Okay, or you can write directly fx is equal to 1.2, and here you write fy is equal to 1.2, and let me run once again. Yeah, you can see. So the resize up image by defining the scaling factor. So this is how you can use. Like if you don't want to like make it too complex, so that time you directly write fx is equal to these values. Okay. Now the second one we can say that ki resizing the image with the different interpolation method. So here we have seen the one is the interlinear. This is the default one, and in the upper one we have seen the intercubic. So let's run this code. So same here I have written. I have taken the original one, then scale down. So for if I am scaling down, na, so that time I am using inter nearest as the interpolation value. So let me run this. So you can see this is the one interpolation value. The second one we have taken the interlinear. Again the same I have taken. So this is the image with the interlinear interpolation. And in the third one I am taking the inter area. So this is the third value. So likewise you can use the different interpolation value and see the effect on the images. Now here what I have done, I am just concatenating the images, that earlier images. So these three images I am concatenating the effect of that interpolation on like cv2 dot inter nearest effect on. I have taken in this variable like res inter nearest. So similarly, I am just combining all these three values. You can see res underscore inter underscore nearest, again interlinear and inter area. So all these values I am combining or concatenating into the vertical image variable. So this is the variable. Here I am just combining all the three images into one, and I have just displayed over here. So you can see this is the actually that last image is not showing here due to the size of the image or the display size, but it is there. So if you want to write now, here I have written that image in this as a output.jpg. So let me show you here. Let me check my default path. So in c colon users hp. So let me show you that output.jpg as a image name in c colon. So c colon users hp, that output.jpg image is there. So this image. So let me open that image. Yeah, you can see the three images we have combined into the one. So this is the concatenation of the image. Now we want to see the cropping an image. So again, like if you want to like crop an image, so how to crop it? Okay, so again for cropping an image we are just first reading the image. So here you can see I have taken the same dog image and into the input one variable and just showing like original image. So here you can see this is the original image with this dimension, that is 640 by 427 comma 3. Now I want to crop an image. So let me show. So for cropping image, you can crop image using the same method, that is the numpy array slicing method. So here you can see I have taken one variable, that is crop image, and I'm just giving the original image. That original image is there in the input one variable. Here you can see input one. So that input one, and here I am using the array slicing. So the you can see the first one, the first dimension is always the number of rows, or we can say the height of the image, and the second dimension is the number of column or the width of an image. So this is how we are passing. So you can see this is our original image, and this 80 is our start row value, 280 is the end row value, and 150 is the start column value, and 330 is the end column value. So this is how we are specifying, because we want to cut the or crop the particular region. And again I'm just displaying that value. So let me run this and show you. You can see the origin from that original image we have cropped only this particular portion, so with the help of that array slicing method. So this is how you can crop an image. And again suppose I want to like use this crop image and I want to paste it into the another region, so that we can do. Now in the next one, here I want to show you the how to like rotate the image. So again the same syntax, you can see here. Let me show you the syntax first. Let me run this. You can see the earlier image, and this is the rotated image. So how I have rotated over here? Rotate 90 counterclockwise. So again, for this there are different values are there, and you want to see the syntax. So just press Shift Tab, and here you can see rotate source image, rotate code, or here you write that how you want to rotate, like rotate by 90-degree clockwise, then rotate by 180 degrees clockwise, rotate by 270 degrees clockwise. So likewise you just mention the that value. So this is the syntax, and simply you can rotate the image. Now here we have cropped the image, right? So that image I want to copy, or I want to copy particular region of an image and I want to paste into the same image. So how we can do? So for that we can say ki copy a region to the another in an image. So how we are doing? So for that we want the region of interest. Okay, so we have already seen ki what is that region of interest. So from a particular image we want to like particular interested region. So how we can copy that region and pasting into the same image. So this we can see over here. So for that I have taken the another image, that is this image, Messi 5 image, and that I have taken into the input one variable. Now here what I am just specifying, here I am defining the region, like which region I want to copy. So that I am specifying over here. So similarly you can see the first dimension is the starting row, and here you can see this is the starting column value, again end row value and end column. So these values I am mentioning over here. So I want to copy the region. So I'm taking the region as a variable. Then from that original image, that is from the input one image, I'm just taking this particular portion. That is here you can see start row. That means which value? 260. Then end row, that is 310. Start column, that is 270, and end column, that is 350. So these four value we are passing to my from that original image. We want to copy that values, and we are copying into this region variable. Now here you can see what I am doing over here. So I am pasting that region into the new location. So again in the original image on this particular location I am just pasting that region value. Okay, so that copied value. So here you can see on which region. So here 10:60. So again the starting row, then here you can see the end row, end column, start column and end column. So this is how you can use the slicing over here. So this region copies from the coordinate this, like 10 comma 10 to 16 and 30 to 110. And you can see, let me run this. Yeah, you can see I have copied this particular portion. The portion is here. This particular portion I am copying and pasting into this upper region. So you can see how we can copy and paste the region into the image. So here on the upper border, why it is there here? Because you can see I have mentioned the starting row value as a 10. Okay, and then 60 as the value, and here you can see 30 and 110. So this is a width and height you are mentioning over here. So at this portion it is copied. So this is how you can do the operations on the images, and these are the some of the operation, that is the resizing an image, cropping an image, rotating an image, and copy a region to the another in an image. Thank you.